Alrighty, we are online. Hopefully my stream stays working tonight. There's been some finicky issues with the connection this evening, and I haven't been able to figure out what it is. So if things get spotty, I'm sorry for the video quality. Hopefully you can find someone else who can give you a much better stream. After yesterday's performance, maybe you can find a better stream in the first place anyway. We'll see. Speaking of which, actually, I can pull this up now. Let's see, day 6. So, one thing I did find out, based on a couple of hints from people, first of all, there's this awesome tool for Clojure. I can set a dynamic variable, unchecked math, to warn me on boxed, and I believe that means when it's doing any sort of reflection or boxing or unboxing of numbers, it'll let you know. So when I turned that on, it let me know that there's a few places where it's doing boxing and unboxing, but the most critical place, it was doing a lot of boxing and unboxing right here in distance, and I think that's because math/abs takes in, I think, either ints or longs. I think there's like variants of that signature. I might be mistaken. Either way, it didn't know what to call, or it was doing boxing for some reason. Adding type hints here massively accelerated this solution to the point where it runs in only a few seconds as opposed to waiting around a whole minute for it to build that map. So it's something that I'm going to be using now from now on, I hope. I've already tossed that in my header of this day's file. So it actually shows up in Emacs too pretty nicely. It lets you know, hey, you probably should check this out. How much time do we have? 48 seconds? Okay, I'm just going to run it. And you can actually see it's marking out other places where it's boxing and unboxing. But these are just one-shot calculations, so I'm not worried about it for now. It's neat. Little tools like that that you find when people point them out that I'm hoping we will find really useful in the future. I'm going to go ahead and... Oh, there it was. It gave me the answer and it flashed away. That was like, what, 20 seconds? 15 seconds? Not bad at all. Anyway, are we ready? We got our problem coming in 10 seconds. 5, 4, 3, 2, 1. Okay. Ancient Nordic Elvish. Great. Wait, what's that linking to? I gotta check this first. Is this from 2015? That's fantastic. I'll have to check that one out later. Swapped up the music tonight too. We're doing Tangle Deep and Dungeon Mans. Also from Zircon. Okay, we got a dependency graph. Okay. So what I'm seeing here, this is a classic, what's it called? Breadth first search dependency. I'm forgetting what the term is. I'll have to look it up again. Whoa. Gotta be careful here. The puzzle input, there's going to be a lot of steps, I bet. Okay, not too bad. Okay, right. And let's get that into our buffer. Let's get a parse out. We parse Align step by rest of Ari matches step Ari line. So if I parse step first of input, he did not like that. Character cannot be cast to Java line character sequence. Okay, there we go, and that should be the first thing we saw. WB. Okay. Dependencies are input, first step. Oh wait, I don't need first here. Meh, okay. Not worth it. Come on. Okay. Did not like. Did I swap it again? What's split take? String rate. Yeah, I keep on doing that. I really am annoyed with myself that I keep doing that. Okay. So, take 3 dependencies. I swear there's just going to be a typical graph algorithm implementation for this. If I knew, I used graph library last year for one of the problems after I solved it the hard way. I wonder if that same one can help again. It was just a standard Java library. Java graph. Is it JGraph? JGraph T? Oh, they polished up their, graph algorithms. Where can I see which graph algorithms are available, though? Come on. Nothing. Okay. Java doc for latest release. Let's go. Okay, hold on. Let's try jgraph t dependency graph. Here we are. Okay, let's try this out. Ready? We're going to go over to the project CLJ real quick. Come with me on this grand adventure. Actually, I think there's refactor, introduce, nope, add project dependency, jgraph t, Maven. What's the latest version of jgraph t? Well, that's right, you have a search thing in here. Why am I doing this? This. Okay, let's see if that's enough. Now I have to remember how to actually build the graph. And for this, I'm also going to reference last year's Advent of Code 2017. Let's see. Oops. Not dependencies, vertices. So our vertices are going to be vertices as mapcat dependencies. Cat map? Okay, that's it. Mapcat ID, identity, dependencies into a set. Okay, looks good. You know what? Let's do something. Nah, I don't want to worry about it for now. Default edge. I need a directed graph of some sort. What's a pseudograph? Remind me. Frames. Pseudograph. Directed pseudograph. Here we go. This seems like, yeah, this is what I'm looking for. So I actually want a directed acyclic graph. Okay. Okay, now I need an edge type. What was... I have default edge here. Default edge. Okay, that seems reasonable. Default edge. And in a directed acyclic graph, can I just add edge? I can. Great. Add vertex. We're going to add all the vertices to the graph. Dependencies. Okay, let's try this out. Did not like. Class not found. Oh, that's right. Whenever I... Okay, hold on a second. I'm gonna have to kill my REPL. I have to start my REPL over every time you add a new dependency. So this will take a little bit of time, but I think it's going to be worth it because this is going to make everything much faster, I think, than trying to do all this ourselves. Call me a wimp, but I don't really feel like doing the whole breadth first scan. Then we're going to make a graph iterator. Org dot, there we go. Let's just get the for our graph, and with a comparator this is where I need to look something up here. Clojure less than comparator. I think it's already defined as a comparator. I think this thing already has okay, well, I'll do that. But I will, I think, do what I was considering doing earlier, and that's to map first. So what that'll do is that should give me a character. Nope, I didn't like that. Oh, I should actually run my whole buffer. The Stinger's track. That's silly. Okay, let's try this. Why is it not recognizing it, though? Am I gonna have to import something? Did I miss... I see org jgraph-t here. Do I have the right version? Overview. It's jgraph T130. I do wonder. Hold on, let's try this again. I think the index is bad, is what's going on here. So let's try doing this manually. I'm gonna have to kill Cider. We're gonna go into our project. This is org jgraph-t core. That's probably why I screwed it up, actually, as I didn't use the dash core. And then 1.3.0. So write that, close that down, restart my REPL. Okay, well, I'm slowing down drastically trying this approach, unfortunately. Hopefully, the other thing I'm hoping is that it understands less than as a comparator. I thought that that was already built in, but we'll find out. Did not like it. It did not like it that much at all. But it's not for the worst reasons. I think okay, that seems really silly, but that's just turning our characters into ints. So we're going like to the very extremes of silliness here. But I do think we got what we wanted. So now, how do we use this iterator? We just iterate through it until it's done. I think we can do this by saying not reductions, just reduce so for each new value, that's not going to work, is it? What's the, what am I looking for? Okay, hold on. If all else fails, you know what? We've got a steps, which starts empty, and then we have next. Nah. This'll work. This is kind of a clumsy way of doing this, and it's not functionally idiomatic, but we're working with objects here. We got Clojure, so we have our interop. I'm going to use it. So, if graph, oops, I should be clear here. Dot has next. I think that's the syntax. We're going to recur with conj steps dot next graph iterator. So just grab the next item, toss it onto the end of the list, and continue. Otherwise, we're done. We toss back steps. Easy enough. I like it. I like it. I think that's it. Yank. Okay, let's validate that that's actually what the problem is asking for. In what order should the steps in your instructions be completed? Okay, done. Go. Got it. I love it when you have a prepackaged thing for this. I'm not going to use that too often, but in this case, I'll take it. I'm glad I remember JGraphT. Thank you so much. Awesome library. The documentation's gotten a bit better too. So we're about to be construction. 4 of the L's offer to help. Multiple people working on steps simultaneously. Now this might be where my prepackaged solution breaks down. Okay. Oh boy. So this is interesting. So what you have is a sense where each element of the graph is not only like present, but it's actually held in a sense. So there's now 2 stages to the algorithm basically. One in which a worker commits to finishing a node, but that node is not gone, therefore its dependencies are still locked, and then it is unavailable for other people to use. So it's a resource allocation type of deal where your bandwidth is going to be determined by the number of people who are working side by side. Interesting. Okay. Let's do a couple quick things here. This is part 2. Oh, wow. What? That's not what I asked for at all. Okay, we've got... I might have to actually... This wrinkle means I probably have to implement it myself now. So, all that work, getting JGraphT in here, might be no help at all now. Okay, let me go ahead and... Let me think. So, let's define our time. Time to complete a given step is so, just to take as an example, time to complete B should be 62. It did not like that. Oops. Because I know I'm using ints right now. There we go. 62. There we go. Seems reasonable. Let's see. Actually, you know what? Let's just factor that right in there. 65. Oh, that's funny. So, 61 plus step minus 4. Huh. Let's validate that that continues to give us the same number. Whoops. $62. Okay, that works. Let me think. Now, I've kind of avoided this. I got to actually build out my graph algorithm. So if I recall correctly, in this context, what do? I think multiple steps are available. Workers should still begin them in alphabetical order. So the order will always be the same still. It'll just take from the available set that it can see. Let me think. I'm trying to remember what the algorithm looks like for topographical traversal. So, given a list of dependencies, independent is what I'm going to call it. So, the independent elements of a graph are those that do not appear in the right-hand column, basically. This will get me to the right area. Set. Difference. The vertices, I'm going to have to make this something else. The vertices of a graph there we go. And then this becomes not that, but the vertices of our dependencies. Okay, there we go. The vertices of the graph Oops. So for our initial graph, for example, what's our first independent thing? It might complain of the sort. Empty. No. GRW, so that matches GRW, those are near the beginning. I'll take that as a reasonable enough proof for me that is giving me what I want. Remove from a graph. To remove a vertex from a graph, we basically say we filter the graph if we're filtering a specific vertex from the graph by removing all the items that, removing all the edges that point from that vertex, if that makes sense. Given that we are walking in topological order, we know that there's nothing going to be pointing at us, so we're always going to be just removing the things that we pointed to, and that should give us the next step of our graph, basically, in any given situation. So, for example, if we remove vertex G from our dependencies, oops, well, I just did the exact opposite. So good thing I tested this. These are all the vertexes that G points to. I actually want to filter to not equal. There we go. That seems much more reasonable. Okay, I'm glad I was running tests this time, because that could have been a hard one to find. Okay. Now we need to actually figure out how to walk this thing correctly. And we also have to figure out what's currently in progress at any given time. And this is going to be the tricky bit. Give ourselves a nice domain item there. We need to know what is excluded, so exclusions. So I'm actually going to add this thing here. So that'll be things that are being worked on currently. So then when I walk the graph, see, we have graph workers. Where so we can extract that information out of a worker tuple. Let's see. Let's see if I can describe this in an interesting way. So basically what I want to do in any given time defin update. So how do I take a single worker? Let's start with that. Given a graph and a worker, which is just a time left and a vertex as worker. I'm going to return there's that. If 0 new time left, then new graph is oops. Then we've got we're going to remove that vertex from the graph, so it's gone from consideration. Otherwise, we've still got our graph. New worker is... I'm sure there's a better way to do this. Oops. Okay, writing that. So let's try this out with our tick worker dependencies. We've got 2 seconds left on the clock for this vertex. What do we get? I still see 71 in there. Okay. Let's try. $171, good. $101. If I replace this with that, it should be some less. 7 sounds like the number of vertices we had pointing from G, so that seems reasonable to me. I think we're good to go. Okay. So we're gonna say here reduce tick worker graph workers. So we're just gonna iterate through each worker, chunk that graph up. Oh, that was a rude noise. It's not gonna quite work though, is it? Because reduce is handing back tuples of new graphs and new workers. I can do this in one of 2 ways. One is to separate those concerns and just recalculate the worker twice, which seems really cheap to me. The other is to, well, let's do that. This is actually going to be very similar, I think, but just slightly more nuanced. And I could just take this part, actually, and toss it right in there. So this will just update the graphs only. Ticking a worker is going to go ahead and just return the new worker. This is a better separation of concerns, I think. There's some duplication, but honestly, it's just such a small thing that I'm not even worried about it in the slightest. New workers is filter. I still swear that there's a way to filter out only to non-nil things, but I still can't find it when I looked briefly. Map tick worker on workers. This is just ticked workers. Waiting workers is going to be something that tells me minus max workers, count of ticked workers. So this is the number of workers who are going to be waiting around for work, and that may be able to pull something down. Open slots. Available work is going to be the independent slots in the new graph. And what are my exclusions? I don't have exclusions in here yet, but I can get it from map worker to vertex ticked workers. Work in progress can be that. I should make that a set here. Okay, so I have a work in progress. I have the available work to choose from. That does not include anything that's currently still being worked on. Sorted at that. So, let's allocated work is take waiting workers from my available work. So I can take only as many as I have workers available, and they will still take it in the right order here. Added workers is map time vector time to complete percent of allocated work. So I just make a worker out of it. Actually, I can say, let's make this a function. Defin make into a worker. Oops. A worker for step is made as the vector of the time to complete the step and the step itself. I like that. That formulates well. I actually really like how this is fleshing out. That is tidy. Okay. Map the allocated worker into workers. I like how that reads. I love how that reads. Oh man. Sometimes a solution is delightful just because it reads nicely. New workers is into ticked workers. Oops, I gotta be careful with my typos here. Into ticked workers, added workers. That gives us a new graph and new workers. Because I'm too lazy to put this in a map, I'm just going to put this in a vector. You'll notice I do that a lot, at least at first glance. I usually can go through and do a second sweep with maps, but for now, small enough. Let's see how this behaves really quick. With the, oh, didn't like something there. It doesn't have worker to vertex. Oh, did I not run these? Uh-huh. Okay, that worked. How does tick workers work with an empty graph, is my question. Does it break? Wrong number passed to independent. Oh, I didn't. On this. Seems to behave okay. Take until so, let me see, I'm gonna take while a little neater. Iterate tick workers on an initial thing of our dependencies and no workers. Map second, so we're going to see all of our workers, and take $80. Boom. Okay. So I see 3 workers. For a while. I see 3, 2, 1. Then an explosion of more. Okay, I like how that's looking. So I do want to run this on a smaller set. AKA our sample set here. So drop one. So, let's see, if I had that, my first step would be 3. My worker would grab it with 3. That would fill that one frame. 2, 1. And then when it's 0, I know it explodes in the next ones immediately. So I think we're good. I think our ordering is okay in terms of sequence of operations. You know what? Screw it. Last. This is not going to be quite. I can't apply and. Wrong number. Right, you know, it helps if you add more parentheses. More parentheses everywhere. It's the solution, folks. Note, this channel is not a Lisp parody. Okay. Okay. There's like a second to last, I thought. But last. Oh. Take last 2. How's that sound? Or no, and take while, not and. Let me think here. There's something I'm missing. Oh, that is right. That's my... I'm looking at it wrong. That's my graph and my worker. The worker does his last thing. What's the second of that? Okay, I think it'll give me the right thing. $8.29. Come on. Nope, answer's too low. That gives me a anchor point anyway. My guess is it's something on a one-off error though. See, work in progress is the set of worker vertices. The available work is all the independent items in the graph, in the new graph specifically. That does not include the works in progress. Take up to waiting workers of available work. So let's just validate that that works as expected. I'm pretty sure this is. So if I take 5 of 1, I should just get 1 back. 1. Okay, we're good. Takes the first few items. Those are also should be in alphabetical order. So that should also be grabbing things in the right order. And added workers. We turn that allocated work into workers. And we merge them with the new workers. That seems reasonable. Just to validate this, take -1 of 1 should just give me nil. Nothing. Okay, that's good. My guess is it just remains an off by 1 error somewhere here. I should have the right. So if I have 1, 2, 3, 4, 6. I think I'm just off by 1. 830? Still too low. So I'm not off by 1, or at least not in that way. Let's Let's read the problem, make sure I'm not missing any constraints. "60 seconds plus an amount corresponding to its letter." I think we already confirmed that, but let's double check. Time to complete int at 61. Yeah. Okay, you know what? Gonna do my favorite trick. Thread. Yay! Said no one. Yes, I overused this tool. I'm not ashamed. Take workers. Okay, just to make sure I haven't screwed anything up. And it is giving me the same answer as I was seeing before. Oh, you know what I did wrong? Can you spot it? I'm not having anyone pick up the work that is eliminated. So the very tail, all the nodes, all the vertices at the end that are dangling aren't pointing at anything. No one's doing that work because I'm deleting things from the front down, from the leading vertices to the tail edges. Oh crap, that's a big miss. So our available work isn't just the independent items. Interesting. I'm gonna have to keep track of what's been removed. So let's try this. So here's what I'm going to do, actually. So, see, tick worker, we have deafen, dropped vertices, workers, map worker to vertex, filter, sometimes, come on, evil mode, don't do this to me. It thinks I'm trying to snap, but I'm not. I'm trying to... Evil mode. It doesn't behave well with Lisp sometimes. Okay. Well, we got that out of the way. So, like, given the graph and workers, I think we can make this more interesting. Come on. Worker to vertex. And then we're going to take this and we're going to say any ones that are leaves that don't point to anything else in the graph, we're going to scoop up and make sure we reapply later. So this is going to be let leaves be set / difference between map second graph, map first graph. So the difference between things that are being pointed to and the things that are pointing. That should give us a good set of leaves. Filter by leaves. Okay. It's not workers, that's now graph. New graph with workers. Old graph with workers. Okay. Available work. Let's go here. Exclusions. Interrupt. Does not like. I should check where that's happening. Disjoint. Indifference. I should make sure that this is coming out of set. Still doesn't like it. Dropped vertices. Is there a map set like there is for map V? Probably not. Not a good sign. So for the workers, we filter down to those that have 1 second left and therefore would expire. We get the vertex out of the workers that are going to expire. Vertices, rather. We filter it down to those that are present in the second, but not in the first, so aka they're leaves. Let's try this out with something here. One, two, 2, 3. And workers. Nothing. Good. If that worker was working on number 2, though. Still nothing. If I only had this. Nothing. So it's not working. So this should give us 3. this should give us 2. Set difference should just leave us with a set of 3. Oh, I have this backwards, I think. Shoot. Yeah, I have this totally wrong. So what I need to do, I need to get where all the leaves are going to be from the worker's done. This is exactly the wrong thing. I need to take the worker's work item. So for example, say they finished 2 here. I need to get the item on the other side of that in the graph. Oh boy, okay, I screwed that up. Finished items is going to be basically this. Into a set. Okay, you know what? Let's try this a different route. I'm doing this in a really weird way, I think. So, instead of trying to figure all this out, set old graph, set of the new graph. So we're just going to take all the edges that were removed, and we're going to examine them. And we're going to get, let's see, possible leaves is mapping second onto the diff edges. So we're going to get all the things that were removed, that were being pointed to, that may have been removed from the graph, and we're going to see present vertices, or the ones that are still present in the new graph, are turn this into a set. So those that were culled in the removed edges and ones that are present in the new graph, we want to get the set slash difference of, whoops. So it's going to get all the ones that aren't still present in the new graph. Oops, and I did it again. Keep using the wrong execution form. Pow! There we go. We got it. Did I hit an infinite loop? Ah, no. I'm going to have to kill my REPL. Crap. Crap, crap, crappity, crap, 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 crap. I should be capping it at like 1,000. Okay, well, take 1,000. Okay, well. Let's kill our REPL. Yeah, assessment on link. Okay. That's my bad. Oh, right. So see what I did? I see what I did. Old graph, new graph, not workers. Dagnabbit. That could wreck things, yes. Actually, yeah, there we go. So EB. That was much faster. Tick, tick, tick. I like that. It's now, I can see it chewing through the last items instead. So, instead of doing all this, count. 904. Is that it? That seems more reasonable. Shoot. Man, just too high. Oh, okay, I think I see why. Maybe. Well. Still not enough one. So one thing I have to consider here is the scenario where there's still things pointing to that node. I don't want to make early assumptions, basically. And that union up there would screw that up. This is just plain vertices. That reads a little nicer. Elements, all the vertices in the graph that aren't being pointed to, that aren't being actively worked on, union with any that are dropped. I don't think that's the right ordering here. I don't think this is going to actually help, necessarily, because I don't think that's where the core problem is. I think this should just make it longer, not shorter. Still 904. It's running fast enough that I'm not worrying too much about casting today. It's interesting that I managed to bound it, though. What could be going wrong? So what happens when I tick workers? I already tried this, I think. That's actually really strange. That is really strange, actually. Oh, I see what's happening. Okay. This is going to be 65, I think. $65, $66. It's going to pick up 67. Good. And 65. Also good. So it is picking up the right things at the right times. See here. Probably gotten off by one thing here. And the next step that would complete $65, $66. So it does grab 72. As long as 72 isn't pointing at something else. Does it still grab 72? It does not still grab 72, but it does grab 98. So I'm seeing the right things here. Again, I'm guessing it's just an off by 1 error. Let's just try it real quick. A dumb thing to do. Okay, there's an off by 1 error somewhere. Nabbit. I'm too tired to even try and tally this thing. Okay, it took way too long. Private leaderboard. How am I doing? Doing okay. Norman Richards bumped up there. Nice. Probably pretty bad in the second one. Pretty good in the first one. Terrible in the second one. Still fun. Okay. I've got something wrong somewhere in here. I think it's that first thing that's screwing me up. Because I don't want to count this phase. I want to count only the phases that have stuff in them. Drop 1. 903. I might go back and rewrite the first part to not use JGraph T, just so that's consistent, but I'm not terribly picky about it, frankly. Other than that, I actually like the format of everything else here. Like, everything else here feels fine. This is a lot of work going on here, but it's a very sequential, progressive accumulation of work, and I like how it ends up being phrased. For the most part. Independent might be getting a little sloppy because it's getting bloated with parameters, but I'm fine with it for now. I like how it is as it is. I'm not sure I'm going to change much here. Cool. I'm going to go ahead and let's add JGraph T to the project. Zippity doodle. I'm going to go ahead and stage. I don't want to stage. Oops. These two. Add solution for day 7 in Clojure. Let's see, what did I modify here? I don't want this. Let's commit that as well. Okay. Ready to push. And that's my day 7. Awesome. Hope you've enjoyed, and hope you weren't screaming too much at that off by 1. I probably should have checked that earlier, once I started running out of ideas. Because sometimes it's just simpler to guess and let the machine tell you, hey, no, you're off. And even if you have to wait a few minutes, you're going to be spending that time figuring out your problem anyway. So Cool. I like how this one turned out. Fun to have to grab a library and then find out the library is only useful for one part of the solution, and I'm not going to bother learning the rest of JGraphT for now to actually figure out if I could reuse any of that. I have a suspicion it wouldn't have been any more useful than just going back to straight Clojure immutable, especially for this right here, where I have to get the old graph and the new graph to compare. It turns out it's really helpful to have immutable data for that kind of thing, because I can get the old one and the new one sitting side by side. I didn't mutate to get there. So, I like how this turned out. With that, I guess I'll close up the stream. Hope you've enjoyed. Have fun with having a code, and keep learning languages, especially Clojure. Take care.